In the early 1800s, there was a small locomotive manufacturer in Paterson, New Jersey. Thomas Rogers founded the Rogers Locomotive Works in 1832, and by 1855, they'd produced one of the most iconic locomotives of the Civil War, the General. But in 1891, a 10-wheeler rolled off the line that would become more famous than just about any locomotive in history. Built in 1891 as the W.M. Kelly for the Prescott and Arizona Central Railway, the locomotive would be sold in 1893 to a new railroad in the foothills of California, and from that point on, be called the Sierra Railway No.3. The railroad's rural location and early type equipment made it a perfect backdrop for the movies. Starting in 1929 through today, the Sierra Railway has become one of the most famous movie railroads in America, and the No.3, a true movie star. One of my fondest memories from my childhood was the TV show Petticoat Junction. Ever since I saw the Hooterville Cannonball, the iconic Water Tower, and the skinny-dipping Bradley Girls, the No.3 had a soft spot in my heart. I could never have imagined that 50 years later, our company would have the opportunity to work on the movie star herself. In December 2019, we were invited to take a look at the whistle on the No.3 to see if we could help get her voice back to its original condition. For many years, the whistle hadn't been performing as it should, and it was time to make a repair. So at the end of the Christmas season, the whistle was removed from the locomotive and sent down to us for evaluation. The first order of business was to see if we could confirm who the original manufacturer was. After checking the casting marks and confirming the chamber lengths, there was no doubt this was a Lima 5 chime. But not built for their mainline engines, this one was for their Shay division. The Shays were outfitted with a 5-inch nominal diameter whistle and not the usual 6-inch. The smaller diameter doesn't produce as much sound pressure as its big brother and was better suited for use in the woods. Once we had the pedigree of the whistle confirmed, we started the evaluation of the critical dimensions. It was obvious that the steam admission slit was much larger than normal, and the gap was not concentric to the bowl. In addition, the languid plate was sitting lower than the edge of the bowl, causing the steam to be deflected inwards instead of outwards. The oversized steam slit will cause the whistle to use more steam than normal, and was sometimes done on purpose to reduce overblowing at high pressure. The out-of-round condition on the steam admission slit will cause the whistle to only sound a couple of the notes, and not all 5 as designed. Once we removed the bell from the bowl, we could begin to see that this whistle has had a hard life. The center support that the bell and integral languid plate rest on had been broken off, and a new steel version had been brazed back in place. The bronze bowl had been brazed to build up the edge from steam cutting and then machined round. The Lima whistle uses a 2-inch pipe thread to attach the bell and integral languid plate to the bowl, and this presents a problem for alignment. The bell is relying on a pipe thread to tighten up at the correct distance. We chucked up the bowl in the lathe and checked to see if anything was running out of round. The threaded center support that had been brazed into the bowl was running out, and there was a flat spot on the inner diameter of the bowl. We cleaned up the flat spot on the bowl and then machined down the center support to include a shoulder to be used as a stop. We then added a 3/4 10 thread in the center for a new center shaft that would hold the bell to the bowl. Once we completed the machine work on the bowl, we tried to remove the 1-inch pipe plug on the top of the bell with no success. Since we were going to enlarge the hole for a new nut, we saved some time and machined out the plug. The bottom of the bell has an integral languid plate as part of the casting. This presents an issue when you need to replace the plate due to wear. We machined the bottom of the languid plate flat so we'd have a reference point for all of the other work. The 2-inch pipe threads were then bored out to make room for a sleeve that will slip over the center support in the bowl. The new sleeve was pressed into the bell, then bored to allow a sliding fit onto the center support. The two pieces were mated and checked for alignment. The steam admission gap is concentric and the languid plate is flush with the bowl. We then made up a new center rod and coupling nut for the top. The nut was made with a square recessed head to look similar to the one that was machined out. The poppet valve seat was heavily scarred from use, so we remachined the face of the seat on the lathe and then lapped it into the valve body. All that remained was to return the whistle to the Sierra Railway for a steam test. On March 11, 2020, we returned the whistle to No. 3 and waited for steam. When the engineer pulled the whistle cord, we were disappointed. The whistle sounded as if it were drowning in steam and never developed its full sound. After examining what was happening, we discovered that the gap that we had originally thought was wider than normal to help overblowing issues was actually a machining mistake made at some point in the past. It was also apparent that the poppet valve that had been recently made was not allowing enough steam to pass through, adding to the issue of the whistle not blowing correctly. Luckily, the No. 3 was not going back into service for a few weeks, and we had time to make further corrections. Once we got the whistle back to our shop, we chucked up the bell on the lathe and cut down the integral languid plate to allow a new steel ring to be pressed on. A new steel ring was made larger than needed to allow for fitting to the bowl, and then heat shrunk and silver soldered into place. Once the bell cooled, final machining to size was performed, allowing the steam admission slit to return to a standard size. While the whistle was apart, the poppet valve passages were relieved to allow more steam to pass through. We returned the No. 3's whistle to the Sierra Railway and again waited for steam. When the engineer pulled the whistle cord, it was obvious there was a problem. The whistle was overblowing and not sounding all the chimes. Something had gone wrong. Upon inspection, it was apparent that the repaired center support that had been brazed in place had broken free. Two of the brazing joints had cracked, allowing the whistle bell to rise up and tilt to one side. The increased pressure from narrowing the steam admission slit had allowed the brazing joints to fail and caused the whistle not to sound correctly. The repair involved removing what was left of the center support and machining a totally new piece. The new piece would actually be larger than the original to allow for as much surface to TIG braze as possible. The first step was to remove the old brazed-on piece and then machine the bowl to accept a new support. We added a step to lock the part to the bowl so centering the new part would not be an issue. We machined the new center support from solid brass and made sure the steam passageways were as wide as possible so the whistle would never be short on steam. 4 stainless steel screws were installed to hold the part in place for brazing. Once the piece was complete, we headed to my brother's shop in the Sierra foothills for the final step. Steve chose to TIG braze the part into the bowl using silicon bronze filler rod to ensure there was as much penetration as possible without damaging the original casting. Once the welding was complete, we gave the whistle a test on air to make sure everything was correct. The last step in the repair was to make a new retainer bolt. The bolt keeps the poppet valve from falling into the boiler if the fulcrum arm is removed from the bowl. The bolt that the whistle was shipped to us with was not the original, so replacing it did not affect the historic value of the whistle. We machined up a new hex bolt to match the original drawings of the Lima whistle. Now all it was left to do was return the whistle to the Sierra Railway for a test. While waiting for the engine to get hot, tucked away at the end of the roundhouse was the final piece of my childhood memories, the Sierra Railway's combination car No. 5, or better known as the Hooterville Cannonballs passenger car. The car's been used in lots of movies and TV shows, but my earliest memories of trains revolve around this car and a small town called Hooterville. Once the engine was hot, No. 3 was backed out of the engine house, and the whistle was given its first pull. clear, crisp, and authoritative sound echoed through the area as the whistle returned to its full potential. We gave the whistle a workout with a photo run-by or two to make sure the movie star was ready for her close-up. The whistle now works as it should, and the iconic sound of number 3 has been restored. We have an extreme sense of satisfaction and pride, knowing that we worked on one of the most famous locomotives in the world, and my childhood favorite, the Hooterville Cannonball. Thanks to the good folks at the state of California for putting their trust in us to work on the movie star.